chemistry that's directly related to cosmetics. Cosmetics fall into 6 general classifications: solutions, suspensions, emulsions, ointments, soaps, and powders. Knowledge of these classifications will help you understand product labels and directed use. Solutions are mixtures of 2 or more kinds of molecules that are evenly dispersed, like instant soup and hot water. In this case, water is the solvent. The soup is called the solution. Suspensions also mix 2 or more kinds of molecules, but suspensions tend to separate when left standing and need to be shaken to blend together before using. Emulsions are formed when 2 or more non-mixable substances, like oil and water, are united with the help of a binder or gum-like substance. They are classified as oil and water or water and oil. Ointments are mixtures of organic substances and a medicinal agent, usually found in a semi-solid form. Water is usually not found in this mixture. Soaps are mixtures of fats and oils converted to fatty acids by heat and then purified. Soaps in the cosmetology industry fall into categories of deodorant, beauty, medicated, and antibacterial liquid soaps. Powders are equal mixtures of inorganic and organic substances that do not dissolve in water. They are sifted and mixed until free of coarse, gritty particles. Let's look now at the chemistry of products and procedures for services in the salon. We'll start with shampooing. As a stylist, it's your most frequently performed service and one of the first impressions the client has of the salon and you. Shampooing should be done as often as necessary to remove all foreign matter, including dirt, sebum, which is the scalp's natural oil, styling products, and skin debris. Improper or irregular cleansing creates a breeding place for disease-causing bacteria. This can lead to scalp disorders and even hair loss. Most shampoos are water-based and contain a cleansing agent known as a surfactant. Surfactants are designed to remove oil from the hair. The surfactant molecule has 2 parts, a water-loving part, hydrophilic, and an oil-loving part, lipophilic. During shampooing, the water-loving part is attracted to water and the oil-loving part to oil on the hair. This action causes the oil to roll up into droplets which are lifted into the water and washed away. Water plays an important part in any shampoo. Water is classified as hard and soft depending on its mineral content. Soft water is preferred for shampooing as it allows the product to lather more freely. Refer to your textbook for a list of shampoo types. Rinses mostly affect the surface of the hair by helping to close the cuticle and make hair feel soft and manageable. Getting hair into better shape is the job of conditioners. Conditioners are used on hair that is rough, dry, and damaged by strong alkaline shampoos, chemical damage, or heat styling. Conditioners generally penetrate deep into the hair. Refer to your textbook for a listing of rinses and conditioners. Perms and chemical relaxers are covered in detail in Unit 2. In this chapter, we will focus on the chemical ingredients used to perform these services. Perms allow stylists to chemically reform hair into wavy or curly formations. It starts by wrapping the client's hair around perm tools that are chosen to reflect the desired curl pattern. Next, a perm solution or waving lotion is applied. This breaks the disulfide bonds. It softens the protein structure and allows the protein chains to assume the shape of the perm tool. The hair is then rinsed to remove the processing lotion. Finally, a neutralizer or rebonding lotion is applied and rinsed. The chemical change caused by this product holds the hair in its new position. There are 2 main categories of perms: alkaline waves and acid waves. Alkaline waves are processed without heat and have a pH of approximately 8.0 to 9.5. The main chemical ingredient in alkaline waves is thioglycolic acid or its derivatives and ammonium hydroxide. Acid waves, which are sometimes called heat waves, are generally processed with heat and are usually wrapped with tension. They have an approximate pH of 6.9 to 7.2 and their main chemical ingredient is glycerol monothioglycolate. The main ingredient in most neutralizers or bonding lotions is either hydrogen peroxide, sodium perborate, or sodium bromate. Relaxers change the molecular structure of hair to reduce the texture of tightly curled or wavy hair. A relaxer is usually formulated with a heavy cream base. It's applied to the hair and holds it in a straight position during processing. In addition, a smoothing or pressing action is applied to the softened hair, causing the entire protein structure to relax to a straighter position. A neutralizing shampoo reduces swelling caused by alkaline formulas and reforms the disulfide bonds to hold the hair in its new straight configuration. There are two popular relaxer types in use today, a sodium hydroxide type and an ammonium thioglycolate type. When chemically relaxing hair with sodium hydroxide, the disulfide bonds are broken at point X between the first sulfur atom and the adjacent carbon atom. Thioglycolate breaks the disulfide bond at point Y between the two sulfur atoms. It is important to remember that the chemical action of sodium hydroxide on the hair is irreversible, which means that once you remove the curl from the hair, you cannot chemically recurl the hair. The hair must grow out before additional chemical services can be performed. And remember, sodium hydroxide and ammonium thioglycolate are not compatible. Hair that has been relaxed with sodium hydroxide should never be relaxed with ammonium thioglycolate or vice versa. Always read manufacturer's directions for specific instructions. Curl reformation is another chemical service performed in the salon. This chemical process combines a relaxer and a perm. With this service, tightly curled hair texture is first relaxed. It is then permed to produce a soft curl pattern. The hair is first relaxed with a thioglycolic product, which is smoothed and straightened with a comb or fingers. When the hair has achieved a straightened shape, the thioglycolic product is rinsed. A curl booster and perm rods are used to achieve the new curl formation. The hair is then rinsed again, and a neutralizing or bonding lotion is applied to reform or fix the curl into a lasting shape. This process demands extreme care, since the dual chemical services and the extended processing time can damage the hair. Again, always read and follow manufacturer's directions closely. Hair color products fall into these general categories: non-oxidative, oxidative, lighteners, developers, and vegetable, metallic, and compound dyes. Non-oxidative colors can be temporary or semi-permanent. Temporary colors are non-reactive, direct dyes that only coat the surface of the hair shaft. They last only until the next shampoo. Semi-permanent colors last through several shampoos. Semi-permanent colors are able to penetrate the cuticle layer of the hair versus coating the hair shaft as with temporary colors. Oxidants, often called developers, are products that have the ability to release oxygen, which is needed for a chemical change. Oxidative colors are mixed with an oxidant, such as hydrogen peroxide, which are available in several strengths. Long-lasting semi-permanent colors, sometimes called demi-permanent or oxidative without ammonia, are mixed with low-volume oxidizers to develop the color molecules and aid in the color depositing. These products do not lighten the hair since they do not contain ammonia. Permanent hair colors, sometimes called oxidative with ammonia, use an oxidation system that starts out with colorless molecules. When these molecules are combined with peroxide, a chemical reaction occurs, building colored molecules. These small molecules enter the hair shaft and penetrate the cortex, where they link together and become permanent. Permanent hair colors can lighten the hair's natural colors and deposit artificial color. Lightening is also called bleaching or decolorizing. Lighteners involve oxidation of the natural melanin in the hair. Lighteners or bleaches are made up of a combination of ingredients, including an alkaline substance such as ammonia. They must be mixed with a developer immediately before application to ensure the oxidation process will be at full strength, as the solution weakens quickly. There are two types of lighteners: on the scalp and off the scalp. On the scalp lighteners are gentle enough to be applied directly on the scalp. They come in two forms, oil lighteners and cream lighteners. Off the scalp lighteners are powder bleaches that contain alkaline salts and a strong oxidizing agent. When mixed with a developer, they are much stronger than oil or cream lighteners and lighten the hair faster. Hydrogen peroxide is the most common developer or oxidizing agent used in hair coloring and in hair lightening. It is used in various proportions and strengths, the most common of which is a 20-volume or 6% solution. Grouped in our last hair color product category, and considered to be a less professional category, are vegetable, metallic, and compound dyes. Henna and chamomile are examples of vegetable dyes and are some of the oldest. It's smart to know and understand the ingredients in the products you use. The best place to find the information you're looking for is on the material safety data sheets, which are available from product manufacturers. Read the product labels. All the ingredients are listed in their order of concentration. At present, there are more than 5,000 different ingredients used by the cosmetic industry. Your textbook lists many of the more common ingredients and their usual function. Be sure to become familiar with them. Several products, such as nitrazine paper, a pH pencil, and a pH meter, are used to measure the pH in products. Refer to your textbook for a list of salon products and their pH.